Okay, children, let's start today's new chapter of Conscious Physics ICSE 2026 model. Okay, Selena book, class 10. The new chapter we have to start now. Light beam in B part, that is a refraction of light at plane surfaces. Okay, okay, page number is what? 75. Move to the page number 75. Okay, so in every page I made some points whatever is there in that book. Okay, let's read the paragraph wise. In class 10th we have read about reflection of light from plane and spherical mirrors. The return of light in the same medium, often striking a polished surface, is called reflection of light. Okay, so what is reflection of light here is given. Okay, children, so there is a plane surface. Okay, this is the plane surface. Okay, the return of the light in the same medium after striking a polished surface. Okay, there is a light ray, it is striking this polished surface. Okay, this is the called normal. Okay, and it is reflecting into the same medium. What is its meaning? Means the source of light, it is in the air only, and our object is also, it is in the air, and reflected ray also returns back to air. Okay, this phenomenon is called reflection. Okay, means it is the source also in the same medium and reflected ray also in the same medium, air only. Okay, air to air. What is this? Air to air is happening, right? This is called reflection. Okay, so this is normal. Means why we call normal? Means it is perpendicular to the our this plane surface. Okay, as a polished surface. Okay, so when a light ray falls or passing through this normal, what happens? The light ray will getting back, reverse, back to returning reverse only. Okay, and then we need to understand now what are the angles: angle of incident, angle of reflection. The angle between this normal and this is called the incident ray, is called angle I, that is angle of reflection. This is the reflected ray. The angle between this normal and this reflected ray is called angle of reflection. Here two laws are there. Okay, in third paragraph they give. So in this paragraph only, it obeys the two laws. The angle of reflection is equal to the angle of incidence. Means here angle of I, first law, angle of I equals to angle of R. If this angle is 30 degree, means it also returning back with the same angle to same medium in the air. Okay, if it is vacuum also, no problem. Next, second law, the incident ray, the normal at the point of incidence, and the reflected ray. Okay, this incident ray, reflected ray, this normal at the point of incidence are in the same plane. Okay, right? On the same plane only we can draw here. Next one, they're saying some speeds of the light. Now, okay, before going to next paragraph, first I'm telling you what is a refraction. Here we saw that in this reflection, it is happening in the one same medium, but reflection happens when light travels from one medium to other medium. For example, think this is the one slab, glass slab. So when it travels from air, okay, first it falls on the glass. What happens? Some part of a light will reflect back to the air only, and remaining part will passing through the glass. Okay, when it's passing through the glass, what happens? The speed of the light will be decreases. then instead of going this path, it will move towards the normal. That is called refraction. That is the definition given in this book. The change in the direction of the path of light when it passes from one transparent medium to another transparent medium is called refraction. The direction, the change in the direction of the path of the light. This is the path of the light. It has to go this like this, but it travels in this path. The path is the AB and BC path. B to C should go in AC path only, but it moves in BD path. The path is changed, right? That is called refraction. This is called angle of refraction, and this is called angle of incidence. This phenomenon, when the light passing from one medium to another medium, its path will be changes. Okay, direction of the path changes. That is called refraction. So here also we have two laws. Here never angle of incidence. No, sometimes it is equal. Or when I will tell. Here angle of incidence equals to angle of refraction, not equal. Okay, angle of incidence is maybe greater than or sometimes less than, sometimes it is equal. Okay, sometimes it is angle of incidence also both are equals to 0. When these four cases we need to understand. Okay, when it is happening, come here. Here second para, just they given the speeds of the light. The speed of the light in air 3 into 10 to the power of 8. In vacuum also same. In okay, I need to write down. I will write down 3 into 10 to the power of 8 in vacuum, 3 into 10 to the power of 8 in air, 2.25 into 10 to the power of 8 in water, meter per second, all meter per second, meter per second, meter per second in water. Next 2 into 10 to the power of 8 meter per second in glass. Okay, in diamond, here is the given diamond. So diamond. Okay, somewhere I saw it. diamond. Okay, here diamond, the speed of the light in diamond is 1.245 into 10 to the power of 8 meter per second. It is in diamond. It is in glass, water. This we should know, should remember always. Okay, children. This para over. This para, what they saying? While passing from one medium to another medium, from air to glass, if light slows down means the second medium is the denser. Okay, see, this is the speed. Speed decreases means it passing from medium 1 to medium 2, then medium 2 is the denser. Okay, children, medium 2 is the denser. When the speed of light is decreased, speed of light is increased when it moves from medium 1 to medium 2. Increase means the medium 2 is the rarer than our medium 1. Here denser means the denser than medium 1, like this. Okay, so right, then the first medium, if speeds up means the second medium is said to be optically rarer. Optically rarer, not physically rarer. What is it? Optically rarer, optically denser means, let's understand. In density we can divide in two types. Okay, one is the physical density, another one is the optical density. This is very important. This is very, very important. This is very important. Okay, physical density means it is depends on see here given optical density. What is that? Intermolecular of density of the medium. Physical density, intermolecular separation. It depends on intermolecular separation, and it depends on the speed of the light. Okay. For example, to understand this one, take a water in a jug and beaker, put some kerosene on this one. What happens? Kerosene floats. Why kerosene floats means it is the rarer than our water physically. Physically here, in this case, physical density, kerosene is rarer. Okay, water is the denser. But with respect to the speed of the light, water is rarer and kerosene is denser. Why means the speed of the light in water is more. The speed of the light in kerosene is less. Okay, according to the speed of the light, we are saying which is the rarer, which is density, which is denser here. Here intermolecular space. That's why here molecules are very tightly, a little tightly closed. Here loosely packed. That's it. Till here we understand. Next we have to understand refraction of light. You already we know what is refraction light. Again here one more term is there, reflected light. The light goes back into the same medium. Some part of the light goes back into the air. That is called reflected light, which is moving into the second medium. That is called refracted light. So this is the 10th point I noted here. After what is it? Parallel reflection and partial reflection is happening at the surface. At this place, reflection also happens, refraction also happening. Next point is what is the angle of incidence, angle of refraction. Already I taught in this reflection. This is our refraction, right? You should understand what is reflection difference first. Okay, reflection happening in the same medium. It is happening between two mediums. So the angle of incidence is angle of incidence, angle of refraction. Already I taught all these topics. So page number 76 is in this one some diagrams. They given same diagrams here. You can go through. The third condition, when light passes through this perpendicular to this surface, what happens? Angle of incidence equals to angle of refraction. Both are equals to 0. That only they are saying. And one more thing here they given. Okay, when is moving m1 to m2 means rarer to denser, angle of refraction is less than angle of I. They given table like that only. There's nothing but angle of incidence is greater than angle of refraction when it is moving from rarer to denser. Now when it moves to denser to rarer, what happens? Angle of incidence is smaller than angle of refraction. Reverse. Angle of refraction is greater. That is, angle of refraction is greater than angle of incidence. It's for example, see here. This diagram. This is a glass slab. When light falls like this, it is coming rarer to denser. This is the normal path. It moves towards the normal. Okay, that's why here angle of incidence is greater than angle of refraction. When light travels from denser medium to rarer medium, okay, obliquely it is falling here. This is the actual path, but it move towards the away from the normal like this. Okay, so here what happens? Angle of refraction is greater than angle of incidence when moves from denser to rarer. Okay children, that's it. It's away from the normal, it is towards the normal. Yes, speed is decreases, speed is increases. Speed of the light is increased, density rarer, optically rarer. Okay, this is over. So here we can say the angle of refraction is denoted by delta. Delta is equals to I is a greater and rarer to is a rarer to denser. this is denser to rarer. In this case, delta will become what? Angle R minus angle I. Okay, and when it is moving on falling, passes through the normal, angle of I equals to angle R, both are equals to 0 degree, then we can say delta equals to 0. Okay, that's it, children. Next we have to say cause of refraction of light. Already I thought it is due to the change in the speed of the light, it moving towards here or moving away from there, depends on the where to where it moving. Same thing here is away from the same undeviated. When it is undeviated, it remains the same. Here speed of the light is the same. Okay, in this case we didn't discuss about speed of the light. The speed of the light will be decreased, but direction won't change. The same direction it will go. No deviation. It is undeviated. When is undeviated means question arises, we have to say when light passes through the normal. Here both are equals to 0. So at the normal incidence, angle I equals 0 degree. The speed of light changes, but the direction of light does not change. Over, children. Next video we discuss about laws of refraction.